Welcome back. Next up is Alper. He's Vice President of the Technical Committee at the LoRa Alliance, and he's going to tell you everything around the developments of the LoRa standard. Enjoy his talk.
Hello, everyone. This is Alper Yegin. I'm the Vice Chair of the Board and Chair of the Technical Committee in the LoRa Alliance, and also the Director of Advanced Technology Development in Actility. So it's a pleasure to be here at the Things Conference to be talking about what we do in the LoRa Alliance Technical Committee. So my presentation has 3 parts. In the next 10 minutes, I will quickly recapture the scope of our technical committee and then talk about our recent publications within the last year and the ongoing work we do. We are in charge of defining interoperability specifications among different elements of our architecture, including the end device and network server, joint server, application server. So more than 5 years ago, this activity started by simply focusing on the link layer that runs between the end device and the so-called network. And over time, we have extended our scope to break our specification into different pieces for covering various regions in region parameter specifications. And then we also start marching into what one would call transport layer protocols, such as multicast, group management, and fragmentation, and even into the application stack in order to adopt popular application stacks to run natively over LoRaWAN. And on the network side, we have decomposed the singular network into so-called network server, joint server, and application server. And we've been standardizing the so-called backend interface specs. So each element can come from a different vendor and be operated by a different entity and still achieve interoperability while nurturing a healthy, ever-growing ecosystem. If we look at what we have done in the past year, here are the most notable publications. The link layer specification version 1.0.4. This is the latest version of the 1.0 family. It comes with numerous improvements, and most importantly, Class B improvements, which now can allow indoor gateways to participate in Class B as well, despite not being inside the coverage of GPS satellites. And security improvements such as mandating 32-bit frame counters and ensuring they persist across reboots even for ABP devices, and mandating the device nonce is a monotonically incrementing value, which makes it much more manageable for the network side. And numerous clarifications and tightening and bug fixes went into the spec as well. So while we matured our spec further, we also decided that moving forward, we will always package the link layer specification along with a reference implementation, along with the LoRaWAN certification test tool, and the certification program. So by the time the specification hits the market, the device makers have all the tools they need to jumpstart their device development or the stack development. And we will be maintaining this scheme moving forward for all the future link layer specifications. And the accompanying document, the regional parameters, we have delivered 2 versions of that. And the most important additions to the region parameters has been the new data rates, the so-called LR-FHSS, long-range frequency hopping spread spectrum, which is available for US, EU, and Australian regions. Now, through that, now we can support very low data rates, even in the US, as low as 162 bits per second. And using this data rate also allows us to pack more devices in the most challenging situation, like deep indoor. And also the ability to mount LoRaWAN gateways on the LEO, low Earth orbiting satellites, which are flying above the ground 500 to 600 kilometers. So through that, the even harsher RF conditions are managed, whether your device is in the most remote area in the world or behind multiple walls in a deep indoor situation. which is the case with the metering. We are already able to support that deep indoor now with the new data rates. We're able to pack even more devices and support that under such challenging condition, which increases the network capacity. And the AS923 continues to be a popular regional spec. And in order to increase its coverage to span multiple countries where some countries do have a different band allocation that does not necessarily align with the rest, we have created 3 variants of this region with a different default channel and different band, but still be able to follow the general scheme of this regional spec. And we've been closely following the regulatory development in China and reflecting them onto our spec, which has been reflected in the CN 470 region. And multiple countries have been added to our regional spec. On the backend interfaces side, we've been seeing increased adoption of activation and roaming, which started bringing us feedback from the market. And we've been reflecting that feedback onto the revised specifications we have. So now we can support geolocation even for roaming devices by pushing metadata across the roaming interface. And what we started as counting frames, now the market said they would like to count individual devices roaming into visited networks. And we have built the required hooks into our backend spec so that we can uniquely count devices. And now with this specification, network servers without NetIDs can allow roaming in. Obviously, if they would like to see their devices roaming out, they would still need to get a NetID allocated, which is provided free of charge to any alliance member. And in order to support migration of batch of devices from one joint server to the other, we have extended our DNS-based lookup scheme such that the joint server can be looked up not only based on join UI, but also based on the batch of devices by building the device ID into the DNS query. And various message flow enhancements in terms of covering corner cases and delivering error messages and all that. And finally, on our march towards massive IoT, zero touch has been a very critical requirement. And when it comes to provisioning devices into the networks, one needs to know various identifiers about the device, like the device EUI, the join EUI, profile ID, so on and so forth. Up until now, people have been pushing this information on a piece of paper, which needs to be read and manually typed or sent over email, attachments like Excel, which needed to be copy and pasted. Some of the device makers had already adopted a QR code label that goes on the device to encode such parameters. But because there was no standard, a QR code developed, produced by one maker was not readily usable by a QR reader or a network management system. So we stepped in as TC and generated a technical recommendation that describes the standard format of QR code that can be produced by anyone and go onto any device, and that can be consumed by any network management application, QR code application to inject such identifiers into the networks. So that we believe the zero-touch device provisioning would be a very key element in accelerating the massive IoT deployments. So having talked about what we have delivered, obviously we're still super busy. So the types of ongoing work include the evolution of the current specs, the link layer, the backend, the photo specs. Based on the market experience, we are getting more feedback, and also closely following the market requirements on that. And we're also working on standardizing additional backend interfaces so that we can even achieve greater footprint in terms of interoperability among more network elements, such as gateways and additional interface with the application server. And always, we're adding more countries to the regional parameters spec to ensure standard operation of our devices in various parts of the world. And we continue working on adaptation of popular application stacks. The metering ones being the leading this pack, like wireless M-Bus and DLMS. And while we are on one side developing specs, we're also trying to provide as much guidance to the market as possible. And those are coming in terms of technical recommendations for device makers, for roaming networks, and how to securely deploy LoRaWAN in the infrastructure. Plus, we have the ongoing new project proposal process in the Alliance, which will bring additional work items to the technical committee. So that's all in a nutshell. Obviously, among the participants who are LoRa Alliance members, contributor, institutional, or sponsor, we would very welcome your engagement in the technical committee. And if you are not a member, and if you would like to be part of this journey and contribute to this exciting technology, we highly recommend you join the Alliance and come and participate in the technical committee. And if you have any questions, feel free to reach us at the LoRa Alliance. And with that, I'd like to thank you for listening and hope to see you in the future again. Thank you.